Captain Bob is scheduled to fly 3 flights today. His itinerary begins in Salt Lake City. From there he will fly a southeasterly course until he arrives in Albuquerque. After landing in Albuquerque, he will then take off again and head southwest towards Arizona and eventually land in Phoenix. For his 3rd flight, he will depart Phoenix and head due north back up to Salt Lake City and call it a day. But Bob has a problem. He forgot his flight bag at home, so he doesn't have his navigation charts. He is already late and doesn't want to run home and be delayed further. Bob thinks he can figure out how to navigate without the use of his missing charts. Fortunately for him, he does know the distance between each city, but he can't remember what heading to steer once he takes off. Let's help Captain Bob find the angles of this triangle so he can be on his way. Let us begin with what we know. Side length A is equal to 328 miles, side length B is equal to 507 miles, and side length C is equal to 493 miles. In order to find the angles of this triangle, we must use trigonometry. Specifically, the law of cosines is the method we will use. Before we go further, it is a good idea to estimate the solution so that after we make our final calculations, we can check our work and ensure that the answers are reasonable and correct. Let's redraw our triangle and take a closer look at each of the side lengths. You may notice that the lengths of side B and side C are both roughly 500 miles. That means 2 side lengths are nearly the same. Therefore, this triangle resembles an isosceles triangle. To be clear, it is not an isosceles triangle, as the 2 sides would need to be congruent for that to be true. However, it is close to isosceles, and since we are simply making an estimation, this will suffice. Now let's take a look at the length of side A. Side A is 328 miles and is roughly 2/3 of the length of sides B and C, which are approximately 500 miles each. Let's compare that to an equilateral triangle, where all 3 side lengths are equal and each angle is exactly 60 degrees. If our triangle was close to being equilateral, side A would have to be closer to 500 miles, but it is not. It actually appears our triangle is more elongated than an equilateral triangle, which means angle A is less than 60 degrees. Since side A is approximately 2/3 of sides B and C, let's guesstimate that angle A in our triangle is roughly 2/3 of angle A in this equilateral triangle. 2/3 of 60 degrees is 40 degrees. Now let's take a look at angles B and C while we recall an important property of isosceles triangles. That is that the 2 angles opposite to the equal sides are congruent to each other. So in our estimated triangle, angles B and C are close to being congruent. Lastly, we know that the sum of the measures of the angles in any triangle equals 180 degrees. Angle A plus angle B plus angle C equals 180 degrees. Let's take all of this information and apply it. We have determined that angle A is roughly 40 degrees and angles B and C are equal to each other. We will call their value x. So, 40 plus x equals 180 degrees. 40 plus 2x equals 180. Subtract 40 from each side. 2x is equal to 140. You then divide by 2 on each side, and you get x is equal to 70 degrees. So there we have it. The angles of our triangle are estimated to be in the neighborhood of angle A measuring about 40 degrees, and angle B and angle C being in the ballpark of 70 degrees. Now let's calculate the exact answer. When you know all 3 side lengths of a particular triangle but don't know any of the angle measurements, the law of cosines is the best method for solving the unknown angle measurements. Consider our triangle ABC. The law of cosines tells us that a squared equals b squared plus c squared minus 2bc times the cosine of a. This form of the law of cosines is useful when you know 2 side lengths of a triangle and the measure of the included angle, and you wish to calculate the length of the 3rd side length. However, that is not our situation here. We know 3 side lengths, but no angles. Therefore, we need to rearrange the equation to solve for the missing angles. Through a little algebraic manipulation, the rearranged form looks like this. The cosine of A equals b squared plus c squared minus a squared over 2bc. This is the form we will use to solve our problem. Now that we have our strategy, it is important to understand that when using the law of cosines to solve for an unknown angle, we should begin with the largest angle in order to determine if it is acute, obtuse, or a right angle. If the cosine is positive, the angle is acute. If the cosine is equal to 0, the angle is a right angle. And if the cosine turns out to be negative, the angle will be obtuse. If it turns out the angle is obtuse or right, obviously the other 2 angles are acute, as no triangle can have 2 obtuse or 2 right angles. So side B is the longest side, therefore the opposite angle B is the largest angle. We will begin with this one. Using the rearranged form of the law of cosines, we must make one more adjustment. Since we are solving for angle B and not angle A, we must substitute the A's and B's in our equation. This works for any of the three angles in our triangle. Our equation will now look like this. The cosine of B equals A squared plus C squared minus B squared over 2AC. Now let's plug in the numbers. The cosine of B equals 328 squared plus 493 squared minus 507 squared over 2 times 328 times 493. We then get the cosine of B equals 107,584 plus 243,049 minus 257,49 over 323,408. The cosine of B would then be equal to 93,584 over 323,408. When plugged into arc cosine, we get the arc cosine of 93,584 over 323,408 is equal to B. Enter that into our calculator, making sure we're in degrees mode, and we get the angle B is equal to 73.180 degrees. Now that we have one known angle and three known side lengths, we can either use the law of sines to solve for the second angle, or we can use the law of cosines just like we did to solve angle B. Since we should use the practice, let's continue using the law of cosines to solve for angle C. Remember, before we can plug in the numbers, we need to rearrange our equation to solve for the cosine of angle C. It is as simple as replacing the A's and the C's from our original rearranged form of the equation. The cosine of C equals B squared plus A squared minus C squared over 2BA. Now let's fill in the numbers. The cosine of C equals 507 squared plus 328 squared minus 493 squared over 2 times 507 times 328. We would then get the cosine of C equals 257,049 plus 107,584 minus 243,049 over 332,592. When simplified, we get the cosine of C equals 121,584 over 332,592. We then plug this into arc cosine, giving us arc cosine of 121,584 over 332,592 equals C. Angle C is equal to 68.558 degrees. Now we are almost done. Let's subtract angles B and C from 180 to find angle A. 180 minus 73.180 minus 63.558 equals 38.262. So there it is. Angle A is equal to 38.262 degrees. If you recall our initial estimate, we said that angle A should be around 40 degrees and angles B and C about 70 degrees. This estimation is close to our final answer and gives us confidence that our final answer is indeed reasonable and correct. Our triangle is solved. Captain Bob is on his way, and he knows how to get there now, thanks to the law of cosines. Next time I'm sure he will remember to bring his navigation charts.